Going to be a blood smear slide, which you probably saw in ap2 at some point, but maybe you didn't know what all the cells were just yet. So this is what a blood smear slide looks like, and you're going to need to identify the different things on here. What do you suppose most of these red things are?
Red blood.
Those are red blood cells. Okay. What do you suppose most of these little tiny dots are here? Those are the platelets, all right? So the weird ones, the ones that are going to give you possible difficulties, are all these purple ones, these bigger purple ones. What are those, do you suppose? Those are the white blood cells. Now, this slide, I think they kind of got lucky when they took this. A lot of times, you won't see that many white blood cells on a single slide. If you listen to my lecture, in a microliter of blood, which is like a cubic millimeter, a microliter is incredibly small. In a microliter of blood, you'll find 5 million red blood cells, whereas you'll only find about 7,000 white blood cells. So the red blood cells greatly outnumber the white blood cells, which means that when you look under the microscope, you probably won't see that many white blood cells. You're going to have to scan around and try to find some white blood cells. You may see one or two, depending on how closely you're magnified, but you're going to have to search around a little bit. Let me show you some more pictures here. So this is just a little bit closer up. The stain is a little bit more pale. Again, though, these would all be the red blood cells, and then they're showing some platelets. You're not seeing any white blood cells in that picture. This one is just another, faraway shot showing you some red blood cells. There's a few platelets thrown in here, but you're not seeing any white blood cells. Okay, so let me talk about the white blood cells, since those are the ones that are going to give you trouble. How many, for those of you that listen to the lecture, how many types of white blood cells are there?
5.
There's 5 types, okay? There's something called neutrophils, eosinophils, basophils, lymphocytes, and monocytes, okay? And your job is going to be able to differentiate the 5 from each other. And I'd say it's fairly easy, but there's one that's sort of somewhat tricky for students. First of all, let me just tell you this. Let me write the names up here. So, of your white blood cells, there's 5 types. Neutrophils, they're called lymphocytes. Monocytes, eosinophils, and basophils. The video goes into way more depth about it, but those are your 5 types of white blood cells. And I also put them in order up here from most frequent to least frequent, okay? So what does that mean? That means that when you're looking under the microscope at some blood, chances are the first white blood cells that you'll encounter are going to be some of those neutrophils, okay? Neutrophils, make up probably around 60 to 65% of the white blood cells. So they're the most common, and chances are you're going to find them pretty quickly. The next most common is 20% or something like that, are your lymphocytes. And then you have monocytes, eosinophils, and basophils only make up 1% or sometimes 0.5%. You have a really hard time finding basophils, all right? They're really, they're pretty rare. There's a memory trick for this. Anyone know the memory trick? Yeah, the memory trick, I don't know who came up with it. Never let monkeys eat bananas. I don't know, it seems kind of mean. Never let monkeys eat bananas, all right? So let me show you what these guys look like, and I'll go kind of, actually I'll go in a different order, you'll see, but anyway. This is what a neutrophil looks like. Neutrophils have these crazy, what are called multi-lobed nuclei. This whole thing is one nucleus, but it's sort of partitioned into what are called little lobes, okay? So if you see a crazy nucleus that has all these different lobes to it, it's going to be a neutrophil, looks like. Let me show you another picture. Here's another picture. Again, crazy multiple lobes to the nucleus. This, on the other hand, is an eosinophil. Eosinophils got their name because they love this particular stain called eosin. And eosin, when it stains things reddish or pinkish. So the key thing with eosinophils, they'll have, if you look in the cytoplasm, they'll have these big chunky red dots to them. Okay? So if you see big chunky red dots, think eosinophil. The other thing with an eosinophil is it has what they refer to as a bilobed nucleus, and it kind of, sort of, I've heard it compared to different things. Some people say it looks kind of like headphones, right? So you got the two headphone part and then the little connector between it. But that's what the nucleus looks like on an eosinophil. Here's another picture. Again, fairly chunky red dots, and then this bilobed nucleus, think eosinophil. This is a basophil. Basophils got their name because they like a stain that has a basic pH to it, and that particular stain tends to stain them very dark purple. Okay? So if you see big, chunky purple dots, it's going to be a basophil. The other thing too with a basophil, it's really hard to make out the nucleus per se. Okay? You see all these big, chunky purple dots, but you don't really see a well-defined nucleus at all. Okay? This guy, again, is rare. Search around if you want. You're going to really have to look hard. I don't know. There's been terms that have gone by where no one's found a basophil, including me. So, go nuts. Extra credit, immediate A. Just kidding, no immediate A. So that's the basophil. Here's another picture of a basophil. Again, you don't really see the nucleus. You got big, chunky, purple dots. Okay, so that's a basophil. Now, what students sometimes get basophils confused with are lymphocytes. These are lymphocytes. I know you're probably looking at it now and seeing they don't look that similar, but sometimes they can under the microscope. Lymphocytes are the second most common type of white blood cell. So chances are, if you think you're looking at a basophil, you could be, but you might be confusing it with a lymphocyte because those are a lot more common. Okay? What can I say about lymphocytes? One thing that's different is just the total size. If you go back to the basophil is bigger than the lymphocyte. These are some red blood cells for comparison. Look at the size of the basophil, and then if you go here, it's not really that much larger than some of your red blood cells. So lymphocytes are smaller. The other thing too is there is a very well-defined nucleus. It's a big nucleus, and it's got a very sharp line to it. Okay? Sometimes it looks like it's all nucleus. So sometimes you may see something like this, and you've got just a very thin rim of cytoplasm. And I think that's why sometimes students confuse these with basophils. Like if you can't see that thin rim of cytoplasm, and you just see a big purple dot, sometimes students are like, well, wait, that's got to be a basophil. All right? Look for chunky purple dots, though, and that's going to lead you down the path of basophil. Here you don't really see big, chunky purple dots. Okay? Let me show you another picture of lymphocytes. Here's some more lymphocytes. Okay? Notice, again, if somebody just looked at that, you might say, hey, that's a basophil. But look for the little thin rim of cytoplasm, and look for the sharp edge of the nucleus. And that should tell you that, hey, that's a lymphocyte and not a basophil. And then the last type is actually the biggest type of white blood cell. This is a monocyte. Monocytes that are larger than all the other ones, which could be useful or not, because probably not though, because you usually don't see a bunch of white blood cells clustered together. But the thing with monocytes, you don't see any big chunky dots to them, and they tend to have what they refer to as a kidney-shaped nucleus or a horseshoe-shaped nucleus. The nucleus is sort of similar to the one you saw with the eosinophil, but instead of having two big things and a small connector that looks like headphones, you've got this sort of bent kidney shape to it. Let me show you another one. Here's another one, looks even more like a kidney. See how it's kind of bent like that? So that's a monocyte. All right, so those are the 5 types of white blood cells. I'll let you attack in a second. You grab your microscopes, see if you can find these. You'll point at some things and say, I think I got a basophil, and then I'll come over and crush your hopes. This is a slide of sickle cell disease. You can see the cells that have sickled up here. We have some sickle cell slides in here. I'll be honest with you, they're not the greatest slides. It's kind of tough to find the sickled cells on there. I don't know necessarily why that is. I do know that, like with sickle cell disease, the cells only really sickle in a low oxygen environment. Otherwise, they tend to have a normal shape. Maybe the ones that were in lab were not taken when a patient was having the sickle crisis, and that's why you don't see as much sickling. But look around. Maybe you can find some sickled cells on our slides. But these slides that are up here are a lot more clear. Here's another one. You can clearly see some of these sickled shapes to it. Anyway, that's all you really have to do in terms of the microscope. The other thing you have to do is the blood typing activity that's shown there. This is figuring out what blood type a person has. If you saw my video, it explains kind of how it works, but basically, to figure out the blood type of a person, you have to take their blood and you've got to test for little antigens that are on the surface of their red blood cells. And you take their blood and you actually put it on a little tray that I have. And I'll let you do this. Again, it's fake blood, so don't be like, oh my God, am I going to get some crazy disease? These are what the little trays look like. Okay. The trays have 3 sort of, I don't know what you'd call it, but little like dish areas on the tray. So this is what the tray looks like. And at one of these little spaces, it says A, and the other little space, it says B, and then on the other little space, it says RH. What you're going to do is you're going to take a drop of the fake blood, and it's so cute. They have different names on them, fake people names. For example, this is Mr. Jones's blood. Anyway, you're going to take the fake blood. You're going to drip like 1 or 2 drops into each one of these spots. Drip through there, drip there, drip there. And then you take 3 different chemicals. These chemicals are called anti-sera or anti-serum. And you want to read what the label says. And like there's an anti-RH one. You're going to want to put like a drop of that and mix it with the blood that's in the RH spot. There's another one that says anti-A. You want to drip that into here and then mix it up with like a little toothpick that they have. And then there's the anti-B one, and you drip it into there and mix it up. Make sure that when you mix it up with the toothpicks, you don't share the toothpicks between, right? Use a fresh or different toothpick each time you're like mixing it up. So what should happen? Well, there's 4 blood types, right? There's 4 with the ABO system. There's A, there's B, there's AB, and then there's O. And then with the RH system, you can either be considered RH positive or you're RH negative. Usually when you get your blood type and they tell you what your blood type is, they just say you're such and such positive, you're like O positive or you're O negative. They usually don't say the words RH, but that's what the negative or the positive is referring to. It's referring to, do you have this thing on the surface of your red blood cells, this marker called RH, or don't you have it? So how does it work? So suppose I put someone's blood in here, and you're going to want to give these different chemicals, and then you're going to look for what's called clumping or agglutination. If the particular marker is present on the patient's red blood cells, when you give one of these chemicals, it'll cause clumping or agglutination in that particular spot. If the particular marker is not on the surface of the red blood cells, you won't see any of that clumping. What does that mean for you? When you're looking through, where did I put it? I don't know where to put it. When you're looking at this thing, Sometimes it helps to put like a sheet of paper with some words underneath it. And if you see some clumping, it's really tough to read the letters underneath the test. Whereas if it's nice and clear, that indicates no clumping. You should be able to see the letters fairly clearly. It won't be as, if there's no clumping, it'll be fairly clear. Where if there's clumping, the fluid will get kind of cloudy in appearance. So, let me give you some examples. Say you do all your mixing, blah, 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 and you see some clumping here, but you don't see any clumping there, and you don't see any clumping there. Does anyone know what blood type that would be? That would be A negative, okay? You only see clumping in the A spot, not in the other two spots, so that's considered A negative, all right? What do you suppose it would be if you saw this? That's A positive, okay? Or if you want to say it out, you could say A RH positive, however you want to say it. What do you think this would be? That's O positive, right? O because there's nothing in these guys, and then the positive refers to that there's clumping there. But if you saw this, that's O negative, right? What about this? AB positive, right? See how that works? Okay? If you heard my lecture, which again was just fascinating, this stuff hopefully will make more sense. So definitely watch that. Like sometime, if you feel like you're in a good mood this weekend and you want to get in a bad mood, watch. Who wouldn't, right? Watch that lecture. Anyway, so any questions about what's going on with that? And I'll come around and help you. Hopefully it'll work nice like that. I gotta be honest, sometimes I think these fake chemicals, they get old and it doesn't work quite as well. But
Don't
anyway,
they have expiration
so
date?
try that out. Grab some microscopes, look at some of the, I'll get the blood slides out, look at those.